this time we're going to need to work backwards. What they've given us is the image down here. I can tell it's the image because all my points have that apostrophe, that prime on them, and they asked me to find the coordinates of the pre-image using a matrix. So in other words, I want to work backwards. So the first thing that I think we'll need to do is let's go ahead and set up a matrix that represents our image. So recall from the last video, hopefully you watched that one, we're going to have two rows. Our x coordinates will be on the top and our y coordinates will be on the bottom, and then each column is going to represent a different point. So starting with v prime, we'll have v prime, let's go ahead and label these w, x prime, y prime, and z prime. And so I'll do the first coordinate with you guys, and then I'll have you guys pause it and find the other coordinates. I can see that in my diagram v prime is located at 0, -1, meaning the way I'll express that coordinate is 0 in the top row and -1 in the bottom row. Go ahead and finish finding your coordinates. Pause the video. My answers will pop up in just a second, but go ahead and pause the video and find the other coordinates just like we did right there. So there were my other coordinates. Our next step is going to be figure out what our rule is. Our rule is given to us as a verbal rule, so let's change that into a matrix rule. We were told that the image had already been moved 6 units to the left, so that rule must have been -6 because I want to move backwards. And then I was moved 5 units up, so +5. Well, that's the normal rule. That's the rule that was used to form the image that we see. Meaning to work backwards, I'm going to need to use that rule in the reverse direction. So think of it like this. Let's set up a matrix. I'm going to call this not just the rule, but I'm going to put it in quotes because it's kind of my own thinking. I'm going to call it the backwards rule. We're going to use it in reverse. So instead of subtracting 6, the opposite of that would be to add 6 to figure out where I started. And then similarly, instead of adding 5, I'm going to subtract 5 to figure out where this started. So when we're working backwards, we'll use our rule in reverse. Well, as we talked about in the previous videos and in the video about adding matrices, to add two matrices, they need to be the same size. So since I have 5 columns in my image matrix, I'm going to need to have 5 columns in my backwards rule matrix. So let's go ahead and just repeat that same rule because we're using it for all the coordinates 5 times. So 6, -5, 6, -5, 6, -5, and so on. So I have 5 columns that match up. Finally then, to get our answer, let's go ahead and add those two matrices together. In order to do that, we'll simply add elements in the same position. So in other words, add 6 to everything along the top, and then add a -5 to everything on the bottom. And what we'll be finding are the coordinates of the pre-image, where we started out at. And what I'll do is I'll go ahead and label this, and since it's the pre-image, there's no primes. It's V, W, X, Y, and Z. So once again, why don't you guys go ahead and pause the video, make sure you can get this to work out. My answers will pop up in just a second. Hopefully you ended up with the same coordinates. If not, double check your work or ask me a question. A great way to check this would be to graph this pre-image and see if it does follow the rule. Of course, this graph is a little bit small since our coordinates kind of ended up off the graph. So we'll trust that we did the math correctly, but graphing would be a great way to check if we had a larger piece of graph paper. So here are the coordinates of where the figure must have started out as long as this rule was applied to end up with the image that we see.